So the topic what you're going to see here today is the condition for Rolle theorem and the mean value theorem. So how do you verify the Rolle's theorem and the mean value theorem here? So first I have written the condition for Rolle theorem. So what's the condition for Rolle theorem? F of x is continuous in the interval, closed interval a comma b. So you know what is continuity. So under this we have seen actually in the first part itself we have seen here continuity part. So here what is it actually? First thing, f of x is said to be continuous in the closed interval a comma b, and the next one, it must be differentiable in a, the open interval a comma b. The second condition is f of x must be differentiable in the open interval a comma b, and your f of a must be equal to f of b. So for example, if you see here I have a curve in this case. So here the curve it goes like this. So here it can be like this also. So here what do I say here? The function must be continuous in this case. Okay, it is said to be continuous. It must be differentiable at this point. And here if you see, and this if I take it as a and b, I must have f of a must be equal to f of b. Okay, so this is the condition. So if these three conditions exist, then there will be at least one value of c which belongs to the open interval a comma b such that f dash of c is equal to 0. This is the condition you have here. Okay, so here if you see, if this exists, then in that case there will exist a c belong to a comma b such that f dash of c is equal to 0. So this is the condition for Rolle's theorem. Same way you have the condition for mean value theorem. So for mean value theorem, again if you see, the first two conditions are nothing but the same. So what's the first condition you get here? Your f of x is said to be continuous in the closed interval a comma b. F of x is said to be differentiable in the open interval a comma b, here you have here. And then there will be at least one value of c which belongs to open interval a comma b such that your f dash of c is equal to f of b minus f of a divided by b minus a. This is what you have here. Okay, suppose I have a curve here. So here if you here a and then you have it as b. So here you have it as f of a and what is here f of b. So what is given here actually here? What do they say here? F of x is said to be continuous in the closed interval a comma b. It is given here. It is differentiable in the open interval a comma b. Then there will be at least one value of c belonging to a comma b such that your f dash of c, that is your f dash of c must be equal to the slope of this one here. So what is the slope formula you know here? y2 minus y1 divided by x2 minus x1. That's what we have written it as f of b minus f of a divided by b minus a. So here to do this exercise you need to know these three conditions for the Rolle's theorem as well as for the mean value theorem. Got it? Okay, so here we'll start with the first question under exercise 5.8. So what's the first question under exercise 5.8? What is given here? Verify Rolle's theorem for the function f of x is equal to x squared plus 2x minus 8, where your x belongs to closed interval minus 4 comma 2. So I think you all know, if it is a square bracket, it's said to be a closed interval minus 4 comma 2. So what have you got here? F of x is equal to x squared plus 2x minus 8. This is what you have here. And now what is your f dash of x equal to? F dash of x is nothing but differentiation of this x. So f dash of x is equal to, what will I have? 2x plus 2. When you differentiate it with respect to x, you have it as 2x plus 2 here. Now you know that f of x is a polynomial. So f of x is said to be a polynomial means you here if you see, it will be continuous at all points. In no points it will be discontinuous. It will be continuous in all the points actually here between minus 4 and 2, because if you take f of minus 4 you will have a value. If you take f of minus 4, minus 3 also you will have a value, minus 2 also you will have a value, minus 1 etc. here actually here. So here if you see, it is said to be continuous in the interval minus 4 comma 2 you have here. And the next one is what? F of x is said to be differentiable in minus 4 comma 2. So here if you see, it is also differentiable in the open interval minus 4 comma 2. If it is continuous, if you can say here, it is said to be differentiable also. So here in the interval, it's said to be a continuous polynomial. Okay, it is said to be a continuous polynomial in the interval. Now here I need to show that the third condition is what actually here? Your f of a must be equal to f of b. That is your third condition. So here we'll take the third condition. You know what is your a and this is your b here. A is minus 4 and b is nothing but equal to 2. So we'll find out what is f of a. What is f of a? F of a is nothing but f of minus 4. So what is f of minus 4 equal to here? F of minus 4 is equal to, what will I have here? It is minus 4 the whole square. When I substitute it in this polynomial, what will I get? Minus 4 the whole square plus 2 into minus 4 minus 8. So it is equal to 0. What's the next one? You get f of 2. What is your f of 2 here? Again substitute it. What will I get here? It is 2 the whole square plus 2 into 2 minus 8. That is also equal to 0. So what have you got? F of minus 4 is equal to f of 2. So your third step is also proved. So first one, it is continuous. The second one, it is said to be differentiable. The third one, you have f of a equal to f of b. So that part is also over. Now if it is like that, then what did I tell you actually here? You will have to, what is it actually here? Hence there exists a c belonging to minus 4 comma 2. So here if it's like that, what did I tell you here? There exists a c belonging to minus 4 comma 2 such that your f dash of c is equal to 0. Such that you have your f dash of c is equal to 0 in this case. Got it? So here if you see, your f dash of c is equal to 0. This is what you have here. So f dash of c is equal to 0 means, you know, what is your f dash of x equal to? F dash of x is equal to 2x plus 2, you know here. So f dash of x is equal to 2x plus 2 means, what is your f dash of c? It is equal to 2c plus 2, that is equal to 0. So here 2c is equal to minus 2 and c is equal to minus 1. Now here if you see this value of c, it must lie in the open interval minus 4 comma 2. Does it lie in the open interval minus 4 comma 2? Yes, because here if you say it's minus 4, minus 3, minus 2, minus 1, 0, 1 and 2. So this is how you get here. These two will not be included because it's open interval. So here if you say your minus 1, it belongs to minus 4 comma 2 here. Therefore, what can I say here? Rolle's theorem is verified at c is equal to minus 1. You understood? So Rolle's theorem is verified at c is equal to minus 1. Got it? Yes. Now, similarly, you have the second question. So, second question is what actually here? Examine if Rolle's theorem is applicable to any of the following functions. Can you say something about the converse of Rolle theorems from these examples? That is what is given here. So, here I'll have to examine if Rolle's theorem is applicable in this case. So, we'll see first of all if Rolle's theorem is applicable here. So what is Rolle's theorem? First of all, it must be continuous. The next one is what? It must be differentiable in the open interval, and then you must get f of a must be equal to f of b, and then only I can find out a c, okay, such that your f dash of c is equal to 0, where your c belongs to that open interval, whatever is given here. Now we'll just take the first subdivision here in this case. You've got f of x is equal to integer value of x. So what do you mean by saying integer value of x? Suppose I have 1.001. So the integer value of 1.001 is what? It is also equal to 1. The next one is what? 1.999. If I have it like that, that also is equal to 1. You will not write it as equal to 2. You will take only the value here, the integer value. It is equal to 1. So here f of x is equal to integer value of x for x belonging to the closed interval 5, 9 you get. Now here I say that it is not continuous. Why do I say that it is not continuous here actually? Here, suppose I have it as x and then you have it as y here. When I take for x is equal to 5. So what is your f of x? F of 5 actually. Your f of 5 will be nothing but equal to 5. So f of 5 will be equal to 5. Next is what actually? Your f of 6. F of 6 it goes on. F of 7. F of 8. So here in between there will not be any continuity here actually. Why is it there is no continuity? Because you have only the integer values. I can take 5, 6, 7, 8, 9 etc. In between the values will not be taken here. So you will have it like this. Okay, this is how you have the integer function. This is how you have it as a step. So here if you see the function is not continuous. That is the reason I have written here f of x is not continuous in the closed interval 5, 9 we have written. So if it is not continuous, it is not differentiable also in the open interval 5, 9. Now here we'll check if your f of a is equal to f of b. So what have you got? F of 5 is equal to integer value of 5, that is equal to 5. Here again f of a 9 is equal to, what will I get here? 9, that is also equal to 9. So you get your f of a not equal to f of b, that is your f of 5 is not equal to f of 9. Got it? Now, therefore, I can say that Rolle's theorem is not verified. From the first condition itself, I can say the Rolle's theorem is not verified. But anyhow, I just take all the three conditions. It's a must that you prove all the three conditions and then say that Rolle's theorem is not verified. Now, the converse. What is a converse actually here? The converse is nothing but if your f dash of x is equal to 0 for all non-integral points in 5, 9. Therefore, the converse is not true in this case. That is what you have here. Okay. So, for non-integral values is for example 5.1, that is also equal to 5. For example, you take 5.9, that is also equal to 5 actually here. And that is why we say that the converse is not true in this case. You understood? So, for Rolle's theorem, what did I tell you? Just three conditions you have. First of all, it must be continuous in the closed interval. It is differentiable in the open interval. F of a is equal to f of b. Then only I can say that there exists a c. Okay, so here there exists a c belonging to a comma b such that what will I get here? You will have your f dash of c is equal to 0. This is what you have here. Got it? Okay. Now here we'll go over to the third subdivision. So what does your third subdivision say here? F of x is equal to x squared minus 1 for x belonging to the closed interval 1, 2. So f of x is equal to x squared minus 1 for x belonging to the closed interval 1, 2 here. You know that f of x is said to be a polynomial. So if it is a polynomial, you know that for sure it will be continuous. So continuous, I don't have a problem at all, because when you take f of 1, that is also you will have a value. F of 1.1, that also you will have a value. F of 1.9, that also you will have a value. So you will have a continuous curve. Therefore it will be differentiable also in 1, 2. Now we'll see the third condition. If your f of a is equal to f of b. So if f of a is equal to f of b, what do I say? F of 1. What is f of 1? It is equal to 1 squared minus 1, which is equal to 0. The next one is what? F of 2. What is your f of 2 equal to? 2 squared minus 1, which is equal to 3. Therefore, I say that f of 1 is not equal to f of 2. And thus I can say that Rolle's theorem is not verified. Therefore, what will I say? F dash of x is equal to 2x not equal to 0 for x belonging to 1, 2 you have here. Therefore, the converse is not true in this case. That's we say that the converse is not true. Rolle's theorem is also not verified. And also if you see here, your f dash of x is equal to 2x, which is not equal to 0 for all x belonging to 1, 2, and therefore the converse is not true. Got it? Yes. Now here, the third question here. The third question, if f from closed interval minus 5, 5 to r is differentiable, okay, is a differentiable function, and if f dash of x does not vanish anywhere, then prove that f of minus 5 is not equal to f of 5. This is what they have asked us to prove here. Got it? So here if you see, if f of minus 5, 5, okay, so here if you see if f of minus 5, 5 to r is a differentiable function and f dash of x does not vanish anywhere. So if f dash of x does not vanish anywhere means what will I mean here? Your f dash of x is not equal to 0. Then I will have to prove that f dash of minus 5 is not equal to f of y. So here I can use both theorem, Rolle's theorem as well as I can use the mean value theorem here. So what theorem I am going to use here is the the mean value theorem. So what is your mean value theorem? Your f of x must be continuous in the closed interval a, b. It must be differentiable. Then your f dash of c is equal to f of b minus f of a divided by b minus a. That is what you have here. Now here you take it, since f is differentiable, f is also continuous. Okay, so it is differentiable. You know that it is clearly given in the question that it is differentiable, therefore it is said to be continuous. Therefore your f of x is also continuous. So if f of x is continuous, by mean value theorem, okay, I'll just write it as MVT here. By mean value theorem, there exists a c such that your f dash of c is equal to, so what is your a? This is your a, this is your b. So how do I write here f of b? F of b is what? F of 5 minus f of minus 5 divided by b minus a. What will I get? 5 minus of minus 5. This is what you have here. Now 5 minus of minus 5, what will I get? 5 plus 5, that's nothing but 10. So you know that it's given clearly in the question that f dash of x does not vanish. So if f dash of x does not vanish, what will I say here? Your f dash of x is not equal to 0. So what is your f dash of x here? It's nothing but f of 5 minus f of minus 5 divided by 10 not equal to 0. When you cross multiply, you will get it is equal to 0. So f of 5 minus f of minus 5 is not equal to 0. Therefore, f of 5 is not equal to f of minus 5. You understood? So, you will prove that f of minus 5 is not equal to f of minus 5. The same thing you can do it also by, what is it here? The Rolle's theorem also it is possible. The next set of question, what you're going to see here is based on the mean value theorem here. So using mean value theorem, verify mean value theorem if f of x is equal to x squared minus 4x minus 3 in the interval a comma b, where your a is equal to 1 and your b is equal to 4. So a equal to 1 and b is equal to 4 means what will I write here? This is 1 and this is nothing but 4. So it is in the closed interval a as well as in the closed interval 4. This is what is given here. Now here we'll take f of x is continuous in the closed interval 1 comma 4. That is what is given here. So here we know that f of x is what actually it is equal to x squared minus 4x minus 3. So as I mentioned earlier, it is a polynomial. Therefore, it is continuous in the closed interval 1 comma 4. What's the next one here? F of x is differentiable in the open interval 1 comma 4. So here if you see it is differentiable in the open interval 1 comma 4. Hence, there will at least exist one real number c belonging to 1 comma 4. So I'll have to find out the value of c here. F dash of c is equal to f of b minus f of a divided by b minus a. So what is your b here? Your b is nothing but 4. What is your a here? It's nothing but 1. So it's clearly given in the question. We'll write it as f of 4 minus f of 1. So we'll write what is f of 1 here. What is f of 1? You know what is your f of x equal to? F of x is equal to x squared minus 4x minus 3 you get here. So what is your f of 1? F of 1 is equal to 1 squared minus 4 minus 3. So what is it equal to here? It is equal to minus 6. Next is what? F of 4. What is f of 4 equal to? 4 squared minus 4 into 4 minus 3. That is also equal to, what will I have here? It is equal to minus 3 you get here. Correct? Now what is your f dash of x here? F dash of x is nothing but differentiating this one. So when you differentiate it, what will I get? 2x minus 4. So you will have f dash of c is equal to 2c minus 4 you get here. Now substitute it in this formula. F dash of c is equal to f of b minus f of a divided by b minus a. When I substitute it, what will I get? 2c minus 4 is equal to, what will I have here? It is equal to minus 3 minus of minus 6 divided by 4 minus 1, which is equal to minus minus it becomes plus. So you are left with minus 3 plus 6 you will get. So what is minus 3 plus 6? That's nothing but 3 divided by 3, which is equal to 1. So you will get 2c minus 4 is equal to 1. So what is 2c equal to? Taking it to the other side, it's 5. So c is equal to 5 by 2. So 5 by 2 is what? It's approximately equal to 2.5. So your 2.5 it belongs to 1 comma 4. And thus you can say that your mean value theorem is verified. So once again I'll just brief on the steps here. What's the first step you'll have to do here? F of x is continuous. What is the second step? F of x is differentiable. Now there exists at least one element c belonging to the open interval here 1 comma 4 such that your f dash of c is equal to f of b minus f of a divided by b minus a. So find out the value of c and see whether it belongs to this open interval 1 comma 4, and then you say that your mean value theorem is verified. Correct? Yes. So here similar way you have another question here. So here again I want to tell you, based on the Rolle's theorem and the mean value theorem, generally only 2 marks are asked actually under the Rolle's theorem and the mean value theorem. So just remember the 3 conditions alone for the Rolle's theorem as well as for the mean value theorem here. and it's enough if you understand the conditions and then know how to do it. That's all. Okay, so that you can do it for any polynomial or any function given to you. Now the fifth question. What's the fifth one? Verify mean value theorem if f of x is equal to x cube minus 5x squared minus 3x in the interval a comma b, where a equal to 1 and b equal to 3. Find all c belonging to 1 comma 3 for which f dash of c is equal to 0. Correct? So what is it you have here? Given f of x is equal to x cube minus 5x squared minus 3x. As I mentioned earlier, it's a polynomial. Therefore, it is continuous. The first condition is what? It is continuous in the closed interval. So here if you want, you can draw a curve. Between 1 and 3, you will get a curve here like this somewhat. So here if you see, it is said to be continuous in the closed interval 1 comma 3. It is also differentiable in 1 comma 3. So that part also you don't have any problem. Therefore, there exists a c belonging to 1 comma 3 such that, what will I write here? Your f dash of c is equal to, so what will I write here, children? Your f dash of c is equal to f of b minus f of a divided by, what will I get here? B minus a. This is what you have here. F dash of c is equal to f of b minus f of a divided by b minus a. This is what you have here. Now we'll find out what is f of, so you know what is your f of x. What is your f of x equal to? X cube minus 5x squared minus 3x. This is what you get here. This is your, now here substituted. Find out what is f of 3. What is f of 3? 3 cube minus 5 into 3 the whole square minus 3 into 3 you get. So what is it equal to? 27 minus 45 minus 9, which is equal to minus 27. Now take f of 1. What is f of 1 equal to? 1 cube minus 5 into 1 the whole square minus 3 into 1. It is equal to 1 minus 5 minus 3. So that is also equal to minus 7. Now I need to find the left hand side here. So what is your f dash of x equal to? It is 3x squared minus 10x minus 3. Differentiating it with respect to x. So what is your f dash of c equal to? 3c squared minus 10c minus 3. Just substituting the value of c here. Now substitute it here. What will I get? 3c squared minus 10c is equal to, what is it? Your f of 3. What is f of 3? Minus 27 minus f of 1. Minus of minus, it will be nothing but plus 7 divided by 2, which is equal to minus 20 by 2 equal to minus 10. Got it? I can write it as 3c squared minus 10c. So here if you see, it is minus 3 you get here, and it is equal to minus 10. Now 3c squared minus 10c minus 3 is equal to, taking it to the other side, you will have it as plus 10. So here you have it as plus 7 is equal to 0. Now I will have to factorize it. So how do I factorize it actually here? Factorizing it, you will have it as 3c squared. So here this minus 10 I can split and write it as minus 7 minus 3. Multiplying it, I must get plus 21. So here if you see, I must get it as 21. So you have it as 3c squared minus 7c minus 3c plus 7 is equal to 0. So here taking c common, you are left with 3c minus 7 minus of 3c minus 7 is equal to 0. Now take 3c minus 7 common. So you are left with c minus 1, which is equal to 0. So you have c equal to 1, c is equal to 7 by 3. So if c is equal to 7 by 3, it belongs to, what is it actually here? 1 by 3 you get. C equal to 7 by 3, it belongs to 1 comma 3. Now what can I say here? Mean value theorem is said to is verified. See here, I cannot take c is equal to 1 is not possible. What is the reason? It's open interval 1 comma 3. So 1 will be excluded in this case. So c it cannot, c equal to 1 is not verified here. Only c is equal to 7 by 3. So here in this case, what is 7 by 3? 7 by 3, it will be approximately around 2 point something here. Therefore, I can say that mean value theorem is verified. You understood? Okay, so again, you just a glimpse of whatever I taught you now here. What is it actually here? First thing, show that f of x is continuous. What is the second one? It is differentiable. What is the third one? Actually here you will have to show that your f dash of c is equal to, what will I get here? F of b minus f of a divided by b minus a, where you get your f of x is equal to x cube, f of 3 minus f of 1 divided by 3 minus 1 you get. So find out these values, substitute it, and then find out the value of c. When you find out the value of c, take the values which belong only to this open interval here, 1, 3. Correct? Yes. Now here, the last question you have got here. So what is the last question here? Like we saw for Rolle's theorem, we examined whether Rolle's theorem is applicable or not for the functions. The same way I'll have to examine whether the following functions are applicable for mean value theorem. So what have you got? F of x is equal to integer value of x. So there is one problem with this integer value of x. Rolle's theorem also will not be verified. Mean value theorem also will not be verified. What is the reason? The reason is very simple. It's nothing but because it's not continuous. I explained how an integer function will be. It will be just step. The function will not be continuous. So in that case, if you see here, it will not be continuous here. So you will have it as it is not continuous. So if it is not continuous, it will not be differentiable also. Therefore, mean value theorem is not verified. So here, whether it's asked under 1 mark or 2 mark, you can just blindly write that its Rolle's theorem also will not be verified. Mean value theorem also will not be verified because the first two conditions itself will not be verified here. The reason, it will not be continuous as well as it will not be differentiable. Got it? Yes. Now here the third subdivision, f of x is equal to 1 minus x squared for x belonging to 1 closed interval 1 2. So this is a polynomial, so it will be continuous. You will for sure you will have some curve like this or something like that. You will have 1 minus x squared in the closed interval 1 2. It is differentiable in the open interval 1 2 you get here. Hence there exists at least one real number c belonging to 1 2. So here we'll see what we can do. Here f dash of c is equal to f of b minus f of a divided by b minus a you get. So what is your f of b here? It's f of 2 minus f of 1 divided by 2 minus 1. This is what you get here. So f of b minus f of a divided by b minus a you have here. So here f of b, what is your f of b? F of 2. So find out what is f of 2. F of 2 is equal to 1 minus 2 the whole square, which is equal to minus 3. What is f of 1? It is equal to 1 minus 1 the whole square, which is equal to 0. F dash of x, what is f dash of x? It is equal to minus 2x, because when you differentiate 1 minus x squared, what will you get here? Differentiation of 1 will be nothing but 0. Differentiation of minus x squared will give you what? Minus 2x. What is your f dash of c? It is equal to minus 2c. So minus 2c is equal to f of b. What is f of b? Minus 3 minus 0 divided by, what will I get? 2 minus 1, that's nothing but 1. So minus 2c is equal to minus 3. Therefore c is equal to 3 by 2. 3 by 2 is equal to 1.5, you know here approximately. So it lies between 1 and 2. That's in the open interval 1 2. Therefore mean value theorem is verified. You understood here? So the same function we saw for Rolle's theorem also, the second question. There you saw Rolle's theorem was not verified. What was the reason? You had your f of a not equal to f of b. That was the condition. But mean value theorem is verified. Okay. So basically children here, understand the three conditions alone for mean value theorem as well as for Rolle's theorem here. And as I mentioned earlier, mostly it can be asked for 2 marks.